I know some were waiting for the next one. We are slightly delayed for the 3:59 for the system design. So let me take a break and I'll be back. Thank you. Okay. Are you all still working on it? Okay. So you're still working on it. And because I need to start the system design. So I keep going, you keep working. Okay, either way. Last time we stopped welcome back to system design. Okay. In the last we talked about the case study about the Uber. So we say when we need to build the Uber, like in the beginning, we need to get the user requirements. So let me go back to the all those like requirements. But I didn't really go too deep into those like requirements, go through line by line. Suppose like all this will be the basic. So we know the Uber apps because as the user, as the like passenger, we will know all the features of what we need, right? First, we need to set the destination and also like what's the beginning location. And we need to like estimate fare. And also need to looking for the nearby driver. And also when the driver, it pops out, can they like accept the, pick up the request? That's all we know. Okay, so based on this assumption or like what these like basic features, then we say, okay, it's ready. Then the next part we need to discuss, last time we stopped by is about like planning it. Then we need to know the entities. Entity will be need to, one thing we need to use is if you learn the database, our relational database management. Okay. That's like help us to build. Okay, so what kind of like entity involved inside? And from the lecture we're taking is the online store, like it's the retails, and we have two systems. One's for product, one's for supplier. So in the supplier, and then we have the one table supplier, we need to their name, address, maybe some description, comment, like all the information required. Because this one is kind of like open-ended, but it should be make sense. Like really actually using for our like information. If we look at this table, like this, in this graph, like we have the supplier, product item, and then somewhere we need to contact the supplier. So we need to contact maybe there are some maybe not only salesperson for that company supplier. So that's why we save maybe their name, their address, maybe they have different location of their office, different warehouse, maybe they have multiple warehouse for different parts. Okay, so it may be possible. And we have the product, and then we also need to have like product image. Are we putting them together or separate table? Depends on, because some of them may be missed. So right here, we have multiple product image or without an image. Okay. So if we are right now, we'll keep on using the case study. So right here, we will mainly, we will involve one is the passenger, the rider, and also the driver. And then we need to calculate fare. So all this, the entirety we are included when we decide. So who knows how to draw the ER diagram? Okay, so I like to have like discuss like in white, we have a whiteboard. So if let's say we taking Uber as an example, I want to like based on you also know the ER diagram, right? So can you draw one and then we can discuss together? Okay, so draw this based on the information we provide. So we have three entities included. So okay, it's okay. Yeah, don't worry. Then we can discuss together. Okay. Okay. And I would like to have a ER diagram, including some possible, you can just like put three possible attributes, like 3 to 5. Also, could you also include some like attributes we are going to use? Yeah. Okay, yeah. Just put 3 or 3. 3 to 5 is fine. Yeah. So what kind of things like we need to, what kind of information going to store if we need to calculate? Like for driver, what kind of information we need to store related to driver? Okay, we need to have a car. Okay, then we can talk about car. Okay. And does it require driver license? Okay, yeah, or maybe driver license. Okay, so ID will be driver license. Okay, yeah.
The driver has to be able to know where they are. as well as where they want to start and end their journey.
Okay,
Although that might also go into fair.
right, okay. And what kind of information is what kind of data you're going to store in the field?
The start, getting to places, the distance, how much we're charging per mile.
Okay, so
Yeah, how long the ride's been going on.
okay,
I think fair is, a better word might be ride,
okay,
you know what I mean?
okay. So yeah, we letting want to do, then you can discuss. Because like everyone have your own structure, like design the tables, but we can like base one, then we can discuss like based on this one. How can we like modify or let it look better? Like fit to our like needs, okay. And so we have that we same for the right, okay.
Yeah.
Okay, so you explain. Okay, so based on this one, so you say, okay, second of it. Okay, thank you. Yeah. Okay, so this one, like, is like based on what we have, like in the case study, we have 3 types and type. But still think it's like enough to showing the ER relationship. Don't know when we showing the ER diagram. Sometimes we have like one to many, or like we'll create extra table to show the relationship for different types. So based on this one, anybody want to like have extra recommendation? Like it looks better.
I mean, you might even have like a car ID, you might have like a car.
Would you, okay, so based on this one, for the car ID, so are we putting the same identity or create a new one?
I would assume it'd be a different entity because
Okay.
a driver can change their car.
Okay.
And you might want to keep track of
Okay.
the description, models.
Would you mind to edit? So, based on this one, so how we would like want to change it?
You want to have probably just a difference.
Yeah, sure, yeah, so you can change that.
Or if you have an array for the car,
Like make it a tertiary relation, what you're saying?
no, like just have the car be a car being an array that stores each model. For that, because someone can own more than one car.
Right.
Yeah, they're not gonna be driving them more than one car at a time.
That's correct.
Yeah,
Okay,
They can select your car they're driving that day.
yeah, so I think I mean,
you express, then we can see. Then based on what you have right now, then I will. Let me see. I will go to grab one more, so I'll be back. Oh, the key.
Not every single time. Take a screenshot. Yeah, so you would just screenshot. Search your instance. Basically, we need to show that instance, engineering, PHP, and MongoDB. So after this.
probably not the driver.
Okay, it's a foreign key.
As a
and then-
foreign key.
Okay, so we have, right now we have one more. So we have the passenger, the rider, we have the driver, so driver will be some car, maybe then I will change it to maybe the UID will be
Would be the car's unique ID.
okay. I will then, that means like this one, I will change it to the UID.
Yeah, the car unique.
Okay. This one, okay. So then I will have a connection with this one.
This time,
And suppose the rider and driver, they are not really directly connected.
Yeah.
So suppose we have the here. Like this. Okay, then how about the car?
The car is connected to the line.
So are we going to like this? How do you,
I would.
you would, what, what's that?
Well, the rider needs to know what kind of car they're buying,
Okay,
right? Whenever they, it says, oh, John is pulling up in a black Nissan Sentra.
okay.
And so they usually try to tell you what kind of car they're in, so
They
that
also tell
you don't get into the.
So you don't accidentally get in the wrong.
Yeah.
Okay, so right here, I just like that, explain, so meaning we have
No
the,
family vehicle,
I say
it's like,
like,
oh, sorry.
we have the driver ID. Okay, okay, so I say user ID. No, it's a vehicle ID, so but if we can need to combine information together with the, which, passenger.
Yeah.
Like, you can write for the driver, right? And also which car is driving right now. Okay, if the situation is already acceptable, accept the order. Then how about the situation is not yet paid? So we have several cases, right? Case, for the case, maybe case one. It's like, case one, we have the, pending order. And then case two. We have the, accepted order. Okay, maybe we have the case three. Maybe we have the canceled order. So if based on the situation of these three, do you think this, table is enough for handle all this? No, then how can we improve it? Or do we need to create a different? Yeah, feel free to. You're thinking, like, based on.
Right.
Mhm.
I mean,
The green one you can receive.
all I know is that they don't really have a lot of like more descriptive stuff like the address.
Yeah, for this, we can like extend a little bit, but right now I think you can just like put 3 or 5 is okay. Because like you do not really need to like put the names or like they need to put their credit card information, or let's say, this like more like minor, but we can try to make it like more perfect, like getting more information. But we need to think about, okay, if I need to build a system, right now we get all the requirements. Then we need to do the planning. Okay, design the function. For the based on the ER diagram. So how do we like handle this? Like, are we like put them all together as a one table, then we handle all these 3 cases? Or are we like put them as a separate? Because they have different cases.
It's pending,
Mhm.
accepted, and what's the last one?
Cancel,
Cancel?
yes.
I imagine you probably have some kind of an orders table. And you would have an order status line in the orders.
When you decide the case, when we convert it to really like implementation, just thinking like, how can we handle all this? Like I said, yeah, like if we have, I just really make it like really simplify, at least like we have a brand new order, so we are waiting somebody, the driver to pick up the order, right? Or like once it being pick up the order, so we have a next stage. And or we can have one more. Maybe I'm gonna say, okay, one more case form. Or that's successfully like completed. Okay. So how would we handle this? Maybe one more. So what you now say, if I cancel it or we already complete the trip, then how would you handle it?
Which part of it?
If we have 4 cases, do you think the table or the structure like this is good enough to handle it? Or like, do we need to add extra, tables or like something else to?
We could add a table that simply handles that stuff, which is handles we'll grab the driver will grab the ride. And the drivers will be more open-ended, and whichever driver accepts will move into that slot. The ride will automatically post, we'll have a posting of what, it's kind of like a billboard of, hey, here you go, which do you want to do this? And so you'll have. Sorry, I'm terrible at this. So.
No, oh, yeah, so when you like.
So the ride posts a billboard, help wanted, you want this.
Mhm.
Driver can insert himself, and thus they can both start going. He can start being on his way, thus, there you go, the preload. Once the rider has picked up, both the riders and drivers confirm on their end of the system that the rider has been picked up. And then either side can cancel depending on problems. Yes, it causes the problem, people try to cheat in rides and stuff, but in the same vein, it will be, if they cancel, it can immediately just be dropped off and just help go.
Okay, so why not it's more like real situation? Okay, so based on this situation, do you think that when we implement, so you're like, when you also you mentioned that automatically it's then. When we look at it, it's automatically, but for a system designer, we need to make that automatically happen.
No.
Then how can we make it happen?
What I
Okay.
can say is, so it'll be like a billboard. We will first post the rider will post all their information, the wanting.
Okay.
They'll go to a board. We will send it to where it's for all the drivers to see. It'll pretty much be a unique ID of the driver's request, of the rider's request.
Okay,
And then it'll also tell destination information, stuff like that.
okay,
And then we will then have an open form, like an open button, something that will allow the driver to transfer their information into that table of the person that wants to be picked up, do a person who pick up.
So then to do that, we would need a billboard table.
so that's why we need to have
Yeah.
one table for the people.
Yeah, that's all.
Okay. People table, and then once there's some driver pick up the order, so we'll transfer to a new table.
When the driver, there'll be a pointer to the driver, like, they'll have a foreign key, but the foreign key will be null. And then once the driver accepts, it will fill that null spot with the driver in which has taken the information from the book, who has accepted how do we say this, bounty for worse or better cases.
Okay,
And then it will transfer the pointer to them, so that way the rider will then see the driver's information. It'll be still part of the billboard, I believe, but it could be also.
Why make a billboard? Is my first question.
okay, yeah, why we need to make, so will be overlap with the original one? Or like, are we breaking down this one to like, maybe we break down from 1 to maybe 3 or 2 or like 4? So that's what we're asking like for when we decide, so is it one enough, or we need to like?
The reason I say we do a billboard is that way you don't automatically just assign a rider to a driver. It's like they can look at this, look at all the information that the rider has posted in.
Okay, so okay, then back to the design or something. Okay, so why now maybe I don't think about splitting 1 to 3 or 4. Okay, I will stick to still 1. So how can I make it possible to make it like only 1 table, but I can fulfill like this to all situation, all the use case? How can I do that? Anybody have idea?
Make it like an order table that can, or are you wanting one table?
Okay, so why not we just stay on the 1 table? Then, okay, as a developer, I'm your manager, say, I don't care, I just want to have 1 table, that's it. Okay, so how can we make it success? How can we make it do it?
Just as important, or.
So,
Right, as well.
yeah, so, basically, I just like give some like basic information. So right now we have all the IDs, we have the trip, and also we have the, starting location or the destination. Right here, maybe the time. Okay, so all this information. And this like kind of like it should be like included for the field. Then how can we calculate the fee, how much it should be charged? And then how can we make it possible and make it work with only one table? Mhm.
We put a status on the ride.
Okay, then we
Right.
put the other status.
The ride can have a single digit flag,
Okay,
say 1, for example, for
Okay.
pending, 2 for accepted.
okay, good. Mhm,
And
okay,
And similar to what you were saying earlier, you wouldn't assign a driver off rip. You would build the ride by leaving the driver null and leaving the order as pending, case 1.
okay,
And whenever a driver wants to look at the rides, then you could use your database, sort, and only show case 1 orders.
okay, close, okay, really close to there, okay.
So you assign this right, or you assign this right, won't be a floor, it won't be a, so you can still change it.
So based on this more elaboration, like, okay, so we will say, okay, we have a status. Okay, then maybe I will have one more table, so showing for the status, right? This one,
A
status.
status key.
Okay, so I have the status, ID, and then maybe the name of the status, maybe like the basic information, okay. So, how can we make it success? Just using, SQL. Or like SQL, just like filter based on the status key. So for case 1, for pending order, maybe, one is, let's say one is pending. Okay, so what I need to do, just let all the status is pending. Then I will deliver to the driver. Right, it works, right? And then if those, they already accepted, they will change, when the driver, pick up the order, say to the API server, change the status to maybe I say 2, set it. So it's no longer showing into, to the pending status, right?
And if it's already to tell them that it's not already been picked up.
Yeah, also once it like this one driver do it faster, pick up the status change, right? So we can fetch again. So when you
Stupid question, but how would, what our, system do, like, say, 2 drivers hitting at the same time?
even though it's hitting the same time, like we, it's really hard to really like the nanoseconds still have nanoseconds, but we still have a policy, like some policy say, okay, maybe yeah, so maybe this is a first order, like even we receive, there never happen 2 package. If we know the network layer, is it gonna happen 2 package arrive in the same time? No, never. So suppose there should be 1 package arrive earlier than another one. If they crash, we know we have some protocol to deal with it, like send it again or somehow like do it. So no matter how the final result, our database receive is like 1 is comes out early. And then, okay, of course, do we need to handle it? Depends on you handle which layer of the development. Okay, because we are not really need to deal with the like the lower transport layer. Then we don't have to think about this one in case like this. But of course, it's a good condition because for the system design, we think okay, if in case 2 for the use case, really if 2 driver like practice for exactly same time. Then just depends on which one comes out. Okay, my system already, I would consider this situation is not going to happen, but really happens. Then I just pick the one like first show up. Okay, maybe really the time is exactly the same. Then unluckily, like just for the company internal process, I just have to come first. Or like who have maybe better review, like maybe the start that I will just like when I say, okay, maybe it comes out to drivers. They have the same time. Then I pick the one with a better review, I will assign first. Or it depends on location. Okay, maybe 2 of them, but when I check the radius, like which one have a closer direction, like distance. that will assign to this driver. Then when I add like two more criteria, then it won't have exactly like two, let's say it's going to happen, then I add one more. That's how the system design works. Okay, so when we design type qualification. So, for this table, later when for the project or some aside, we need to do it. But I'm saying there's no, perfect solution, just have a better solution. Or like based on the situation assumption, we need to do, okay. Then I say, how about a breakdown based on all these, use case? Can I break down to, 4 different tables entirely?
Good.
We could.
Yes. Then what you need to do, just like change the SS table to separate, right? Because I know that based on the API, the path, if I need to get pending order, or I change to, let's say, new order, that will just access to the new order table.
Dumb question, couldn't you technically have infinite tables and say, if you made each ride create their own table? Would that be, I know it's dumb, and I'm just asking.
Okay, how do you think? Can we have infinite table?
You could,
Theoretically. It would be
until
a
you run
lot
out of
code.
memory.
Yeah, you would run out of memory.
Well, the table will delete it, the table will be deleted after the ride. Like,
Because-
No, don't delete it.
Okay, so when you ask this question, then I need to ask, do you think the table will generate dynamically or preset? So we cannot change. Or like based on like we need to stop the service, or like when we have a system upgrade, add one more table. So then we need to think about this question. Before like if asking is.
And to stop the search static table.
Kind of not, but you need to like add, like every time update the server, change the table structure. When you have one more table, then maybe we need to change the queue with the SQL, right? Maybe we need to change the API server because we need to access to a new table. Or like how can we fetch all the tables? So do we need to consider this situation? Yes, okay. And if we are the developer, why not? We have team, so why not working on the Ubers? Okay, so which way are we going to do? Are we like keep general? Because based on what you think, I guess we'll say, I have a question, why do we need to have infinite or like?
No, I was just asking.
Oh, no, this good idea, yeah, it's like, there's no dummy question, but it's like always let us to think, okay, can we do it in this way? Yeah, okay, so then what's the reason behind our like, maybe not the understanding of like how to implement the database or like implement the system. So,
Would it make finding like the ride later on, like if you like have like what rides have I taken this week or something, that would technically can sort by.
You can sort through.
okay, anybody here, this question
Stating.
and can answer this question?
Anyway, I'm trying to.
Okay,
Why would you not want?
because he kind of like, actually what you're asking actually makes up the data and the table. When you're thinking like when we generate more data, then we need more table. No, we are not doing this. Our tables will be like how we already think and design and based on the need or the requirement. So we design all the tables, what we need. Of course, like in every table, maybe even MongoDB, we still need to define all this like generate and handle all these things. And the data size is increasing, but only for that table. So if we have a new order, maybe always the new order comes out. Okay. Let's say then we go back to the so like I try to finish your question. If we keep like adding new order, so it comes out like so ending. So we are infinite. Can we have infinite? Of course, increase the server storage, then we can fix it. So by the hardware. So we are not like, of course, not because in this part, but when we talking, we need to think about it. In really we need to talk about, of course, we can like increase the size or like we need to like clone your server, transfer to your new server. So we need to think about this part. Like when we talk about, okay, if the usage increase a lot, then we need to like we need to store them. How can we transfer? We can mention this part in our system design. And I just have follow-up question, like in case I say, okay, let's do it like, I want to do it about different tables. And one's for new order, one is for maybe accept the order, so already like the driver picked up, one is like already some order canceled. Or the trips already completed. If I have all these tables, how will you handle if I have a pending order or new order already picked up? So how are you going to do? Are you going to delete it? Or how will you handle this situation if I use different tables to store all the trips?
If you use different tables, then you would set a flag for this is no longer, you wouldn't delete it, but you'd set it, this is no longer relevant. This is no longer new information. and then
So-
in the new table.
Okay, so you say, maybe I will make it as a thread and then I will move it, copy to another table.
You could
That's
have
a
like
almost okay.
you could have a variable key that distinguishes it, so like what I mean to say is like you can have a slot that says unread and red or new and bold, new and new and red. So, new, you have a key that can swap.
But if we feel like doing things, we have some issue or like some problem, some redundancy.
You're gonna have forward, I mean, say you have a pending order
Mhm.
and then it gets canceled, you now have two copies of the same exact information in two separate tables, so you're just duplicating like the amount of information you have to store. Or not really any, like, because you're never gonna really use the pending order version, you always want to access the canceled version if you were not to refer to records.
So if I say, okay, I'm a city manager, okay, say, no, this time I want to keep four. I just want to, but how can I, like really solve this problem or like make it? I don't want to like really pay or like what kind of considerations, what kind of actions are you going to do? So I make it perspective.
I guess in that case, you want to handle the status of the ride inside the ride, and then once you've determined it's like what it is, if it's a pending order, push it down, otherwise push it into either accepted, completed, or canceled, right? Because if you're having to manage it in 3 different tables at the same time, it becomes, you end up with a lot of redundant data.
Okay.
And you run the issue of, you could have an order that gets accepted and then canceled, but it never gets set to null and accepted. So you just have a ride that never completed, but it was also never like set to cancel or never set to null in the accepted table. And you might end up with like a lot of redundant and incorrect guidance through that method. So I think the best bet would be to handle it in ride and then push it down into a table once it's been, like, once its status has changed.
Okay,
That way, you're effectively using the same function that you were talking about before, where you have a status of the ride and then you swap that value. But this way, it's all handed in one, and then you have a record of it in the 4 different tables, but they're only for records, they're not for handling the.
Like a completed ride.
Yeah, exactly. It wouldn't be for handling the function of it, it would just be for record keeping.
okay, yeah.
Yeah, if you wanted to, if, you know, your manager wanted to be like, hey, I wanna see all the accepted rides on this day, right? You know, I wanna see all the canceled rides, then you will still have them individually stored, you can sort through them, you can refer back to, you know, their UIDs and all the information that's stored within them before they were pushed down to that table. But nothing's actually being like called in that table, it's just like a stored repository.
Okay, yeah, so we have to keep saying. So, also like when we talking about this, also we talk about like the read write time. So, like how many times, like, for one order, let's start from the new order once it pick up. So when we changing the status, they can pick it up and then cancel it, right? So, most of it probably only like execute only once. So when it press like transfer, like from the status is like accepted to cancel, and we can move it. So when we execute, also we need to know like on the server, we need to move one row of the record to another table. So we need to read it and copy it again. Okay, so we have some execution time. So when we designing the system in this way, in meanwhile, same time 1 second, we have over 10,000. So it's gonna be happen, right? So how we gonna handle it? So we have lots of like extended questions to ask, like how we design the system. So how we gonna handle? Okay, or like not only handle it, it's like can our server handle this like so many requests? Maybe we need to like think about the load balancing, like maybe we have multiple server actually to like evenly distribute this order, or like we have like caching, doing the caching for the database. So when we read it, it will be increase the speed. So all this when we think about design system, so we always adding the caching like for the database. We are not every time go to like read the database and then select the data, and then we write the data and then write it back. Okay, sometimes we just read it from the cache, increase speed, and then we can update the cache. When it's confirmed, maybe send. Okay, it's also possible. So after we discuss, like talk about these things, then which one will you prefer? Just one table, handle it, save it, or using 4 different tables to store all these things?
I think one table is more simplified, and you can always like add another table if you need it, but you don't really want to delete a table.
Okay, yeah. In our actual behavior, never, just remember, we never delete any table. Like once we decide for a system, we never delete a table unless we realize that, okay, we make some mistake, like, or we should actually combine to one, then you can delete it again. But for the data we store, we never delete it. Yeah, because like we use it for like statistics, like everything. So even though there are some order they cancel, we still save it, or like some issue we save it because we interested. But after we have like proposing 2 different solutions, they went out and when we. So I think wonder how many of you thinking we should go for one table or multiple.
Question.
Okay, after this, so I just need to. So how many of you thinking just maybe we just use one table? Okay, so it doesn't make sense, right? Okay, yeah, you can do your question. Okay.
You said we're not supposed to utilize data, but is there any concern about where data? No, I'm sorry.
Actually, in certain part we never, we just back up. Okay, or like if we change the, is it possible, or like is it going to happen? We change the database structure, or like I think yes, it's going to happen. Or like when we have some new features that to it, maybe we need to change it. Of course, it's gonna happen. Sometimes like for the maybe the database developer, they need to change it working with the API developer, full stack, they're working together. Okay, so we need to, when we like change the structure, we need to migrate, like change like all those structure, all those data, migrate to a new structure. Then of course we have some content maybe missed. It doesn't matter because like we can, it's a pass. So it's just a doesn't show up. So it's a pass, maybe it's a like previous order or history. So just let it be okay. But for the new one, then we can adapt to the new way. Okay. But we still never delete data. Because suppose you say when you delete it, it should be at least it fits to the requirements or the needs right now. So then it shouldn't have something like irrelevant or right. Yeah, suppose it makes sense. Okay.
It's kind of like, if you made a Minecraft account a long time ago, you probably bought it on Minecraft.net through Mojang. And they had a database of usernames and passwords, assuming. And then, a while back, Microsoft bought Mojang and Minecraft. And if you had a Mojang account, then they're not gonna just go and delete the table just because they got a new company that owns them. They gave you the chance to migrate this account over. And if even today, if your account isn't migrated, you can still go back and migrate. Because they're not.
But what I meant by saying that was just like, an example is like, we have like rides that are like 6 months old. When, how would like, what if you,
Microsoft bought Mojang more than 6 months ago. When does the time stop? I mean, it never does. Right? Until the company shuts down. Yeah. The data is always.
Based on, yeah, because like, kind of like, oh, no, not our case, but just like extra, because there's one, if like this, we have two different login account. Or like Uber too, like just like, if you can, in the beginning, it allow the using your email or your phone, even just for login email, so just, okay. Even we have the user account, so we have the email, phone, and what else? Maybe when you're using an iPhone, you can using Apple ID to log in. Then how do we handle all these different type of login?
I would assume that each different login system has its own API that you can just tap into and use. Right, like Apple probably has like an Apple ID, like login API. Gmail has like its own, Facebook, Microsoft, they probably have their own.
Yeah, we have Facebook.
Yeah.
So, okay.
Like function, they have like their own functionality. So you probably just need to go through each individual API and have a table that handles the different discrepancies and just make sure that it takes that data and then however the API works.
You're talking about the buttons that are like sign in using
Yeah.
Google.
Yeah,
sign in
yeah,
on
that kind of
Facebook.
stuff, yeah.
So, yeah, because when we design, okay, perfect. Because we didn't talk about this one in the user requirement, it's not functional requirement, but it's not just because we are like working for the system. Okay, so when we click on it, we have multiple login. Even actually to it because like for the Apple login, anybody knows like, okay, so Apple login or like Facebook login, how does it work there actually? We will, I think we talk about the API.
I just assume it's some kind of example.
Okay, well, like maybe we have like limited understanding. I know like you're not really networking.
the way I believe it works is you'll sign in to your whichever account you are, and that account will send all the information that is relevant to that company, like for example, name, username, and then you probably will assign yourself a password, or probably just use the Google password itself. And it'll send all that data to the person you're logging in with. Like for example, if you sign into Reddit, when you log in with your Google, they'll probably send all that information to Reddit, so that way they can create you an account that's pretty much just all your data from Google.
Okay, so, so actually how it works, like, they all have an API, so like Apple, Facebook, or Google login, they have their own API. So when you click on the button, we are not, if we are the developer, actually we are not really handling the login, but we just like based on what they input the email, and, even not really handling the email. So you will see when you press it, it will be direct to another page, right? Also, let's say we are using Facebook login. So we follow another page. So actually we are calling the API of the Facebook login. So when you input the Facebook account and password, so they store on their side. So actually, so when we using those API, so those like Facebook will check in. Oh, it's your maybe you are using email and password. So when you type it, they'll match. Is it is a valid account? Is the existing account in match? So they will return authorized key. So they have a key of your email. So when you get this key, it will return back to you. Then we have a question right here because it's pretty common. Then how do you handle this? We can allow the user to create their own email and password. And also we are allowed to using all these like other API like Apple login, Facebook login. Then how can we handle this? How can we build a structure for a system?
There's a,
You create a login table with user
You
data.
want to come enjoy? Yeah.
One thing I just want to point out that we might have missed is,
You can.
one driver can have multiple cars can have one driver. And so we probably would have needed a car driver value pair table.
The tertiary table, yeah.
That's what I said, was that car.
I'm sorry.
Right?
What
I
you
said, one thing we might have missed is that a car can have multiple drivers, and a driver can have multiple cars. So we probably wasn't needing a tertiary key value pair table.
Back to the reality, okay,
Wait, actually, no.
for the case, but is it going to have multiple driver or single?
Could, potentially.
Dang, I didn't, oh
Something
yeah,
you
like,
would-
you have like that, do you have like a student driver car where the teacher can technically drive as well?
Okay, and, because you don't have Uber, driver, I did open it, so I know about this.
Sorry, I have no idea.
Okay, so, when you, sorry to stop you, okay, so I can share this one, because when we talk about system, like based on some really, in high like working, so we need to how to know, they fix this code. You know, for the Uber account, sometimes they will lock you out and they require you to take a selfie. They will try to match with your driver license.
Really?
So they will kick you out, so they will.
You're the one driving?
You are the driver, so because you register Uber account, right? Then you also require you upload your driver license, so they're using AI to match your like face. So they make sure, okay, you're the driver who's driving, this is your car, this is what you register. So is it going to happen, have a like driver or like, this car is owned by me and this is what I register, right? And I drive others, but actually, we don't know this driver driving which car. We don't know, because they don't have system to check, right? Okay, this is, they register Uber X, but actually instead they're driving another car. We have no way to check, but they will make sure the driver is the one is driving, okay. So they do prevent, but they don't care which car they're really driving. Okay, back to yours, okay, for the login, so how would you decide the login? Okay.
I would do it as just a single table that would, if you're logging in through our app, then it would store our own username and password. And then usually if you're logging in through another, like Gmail or something, they'll give you an authentication key.
Mhm.
And so if you're logging through someone else, then you could store the authentication key in this table as well. And then any other settings, data, multi-factor authentication, you could also store in here. Is that the answer you're kind of looking for?
Okay, so if like for those for the like they have a key return, then you won't able to get the sometimes you don't have password. It's empty.
Correct.
Username, nobody no username. Then how would you handle this like?
You can make them null values, you can make a check, just to see if they're null, then check for authentication.
Okay, so that's your how we decide, like, we are using one single table to save, right, all the data. We may have different API to handle all these requests.
I mean, you could even have like just a simple switch statement that's like, if you have an external login key, use this login factor. If you have a username and password, use this login.
Yeah, actually, when we really happen, so when we have a UI, we use. As you can see, so maybe here's the email and the password, email and password, and normally we put the line. Where's the Apple login? Okay, one is the Facebook login, like this way, and one is the Google login. Okay. So when we press on this button, we connect to different API. Okay, so if we are logged into the using the regular login account, actually it's like really how we do it. So we will go to the like just like our standard one is like get the user account, maybe email, or like how about even the I will increase it differently. Okay, so right now is the email and password, and that's it. So it's one API to handle this one, and then we make like 3 different API. One is connect to the maybe Facebook, one is for Meta or like Apple or like Google. So we get the API. Once they return their the authorization key, punchback, just save it. So for this one, maybe we will have a special flag to, maybe one special flag is like, where, maybe one is Facebook key, two, yeah, Apple, or like maybe four, like five, any number, it's the original, like from a default. I will know all these user there from. Because that's how it works actually, if you create your account using your email and password, and if you using an Apple to log in, they will recognize two separate accounts. That's how it works. Yeah, so it's not how we design. So it's normally because why we have different accounts, they are not shared. Because this is how actually we design the system. And if just increase the difficulty. Sometimes they allow login using the email and phone number. Yeah, okay, then how about this part? How about this part?
If you can make it an email or a phone number?
Yeah, so, this one is like called non-function because we are not really like about checking, but after they input the information, it goes to our system. So, anybody have ever see like let you to input maybe not the phone number, but sometimes they allow email or username? Okay, so how will you handle this request?
Could you take it to where you take your username and your password, whatever format your username is in, and could you combine them into like a string and into a string and then Python code it? And so then you have one identifying key, and then you would take the two datas and turn it into a key like your external, like Facebook would give you a key, could you compile that into a key? And as long as they put in the right phone number or whatever, then it'll turn into your key that you want.
I like, I this, other thing. How about? Other thing, please.
Like maybe you would have like some kind of function where if you're doing like username or email or something, you would just have the function check which one of those it is, like is it phone number, is it email? Okay, maybe it's email.
Okay, so you will say one, okay, so we will add one more function, right? So because we need to want to let the user feeling more convenient, have different type of login method. So that means that if we need to have an extra function. That means I will check if the email or it's phone. Okay, so it's an email. Suppose we have an and then with the like really common like Gmail, Hotmail, Outlook, all this. Okay, so it's a good idea. And then for the phone number.
There's like dashes, or maybe you could auto format it.
Okay, yeah, we can set the format or like just limit to the format only like digits.
10-digit number.
Okay, digits. Okay, so it's actually we can do it like this. For combining, then we need to how to think. Okay, if what's the possible problem if designing this app? Like because that's what I'm proposing. Okay, I'm using the phone number and email combined together to generate specialty. What's the potential problem or like what's the difficulty to handle this instead of like using a function tool?
Well, you could never change your username or password, right? Because there's a unique key, you generate a new key every time they changed it. Yeah.
Okay.
Okay.
Okay. Yeah. Okay. So it's like really yes. Yeah. Yeah. Just like back to yours, like the proposing was like it's a pretty common that should be using like for theorem. The login function. Okay. Like based on this table. So yeah, just like summarize because we say about the archive. For the system design. Just feedback with like all those like requirements, we know what they need. Then we need to think about when we design, okay, how many tables, how those like functional things work. So like we need to make all these like even just talk about the login. We have so many possibilities like how we will handle. Your can be one of the solution, but if you comes out like a better way, like say, how can we distinguish or like does it cost more time? Also, we need to talk about the time and cost. For this one, I just need to have a function to maybe using a regular expression to detect it's an email or phone number, and that's it, right? So if I determine it's a phone number, then I will just need to have two different query that's it called. Yeah, just put two, just one API is checking the email, one API is checking the phone number, make sure the password, and that's it. So it's like it may say like your effort or statement like resources to be fixed up. Maybe yours more like high security, but it may cost more. Yeah. So when we talk about the system design, then when you propose a solution or join ER diagram, then you need to tell all these like consideration or like, is it possible? Okay. I wish like based on this one, you will like have a better picture about if we need to ask your like, because like this one is even more than drawing a ER diagram, like you learning database. Database, you just need to tell, okay, one-to-one, one-to-many, what's the possible. But when we go to system design, then we need to think about, does it make sense? Or like, how can we provide, like meet the requirements, like fit to the real situation? Okay. Then we start by the Uber and come back with the lecture, just like follow. So for the activities, so we just like finding all those requirements. Then we already jump with it, and we will talk about the use case. So we need to think about use case. If you really go for this class, as a developer, sometimes you don't really have a chance to doing that, or like maybe you do interview, or really when you become a manager or like as a senior level, then you need to really think about, you need to tell about, okay, so we need to list out all the use case. So possible use case. Based on the use case, then we need to decide like how about the system, like how do we handle the data? Then should be like say one table is enough. And then what kind of function in behind we can deal with it. And maybe when we pass it to the other teammates, they say, okay, we only working on one table. Because when we say only one table, who are involved, like at least the database developer, they just like making like create one table. And then for the API, sometimes maybe if they work with the API or they have another team, they say, okay, so we only getting data from one database, only one table. So how many API methods we need to include, how many routes we should include. And then for the backend for source code, then for each button, then how can we access to those API? So we need to look up all this like information. So based on this, like we have you can see the use case diagram, like help us to capture, okay, so we need to looking for the purchase agent, we need to looking for the supplier, and we need to enter update supplier information and look up the content, and also like update the information. And also we involve different parties. We have different entity, but also different party means like the manager or like some if taking the example from here is the retail store, we have some supplier, so they have like some supplier user, or like maybe some product producer, then also some admin involved. So what are the right, like, or like what kind of data? So are they limited to access certain table, or like only they are allowed to access to certain type of content? Or do they have a right to modify the update, edit, or like they can update it, but they require the approval from the manager, like this. So maybe I'm an admin, but after I change the information, I will post it. So the admin will receive a notification say, okay, we have some like pending modification, request your approval. Yeah, if there's a system like this, then how can we implement? So we need to like think about all this use case. If back to the one like we design, like within 1 hour, I just tell you I want to make an app like Uber. Of course, we couldn't have enough time to cover all this, like everything, all the entities, all the function, but it's more like this about the logic. We need to tell the logic how do we design the system. So like first get the requirements, so we can make some assumption, probably how we use it. So basically we have maybe 3 or 4 use case in our list. Then we can based on this to discuss, okay, how we use, if we have a ride, then one table. Okay. And also we have the diagram of the workflow, and this workflow will create the from starting, like we need to enter the name, and if we can find it, we can return the information, not found, which step is going to do. Because all this with the logic of your function. Okay. It's telling. And once it's ready, then we can see the final layout will be like this. It comes out. Okay. And so far will be for 2 days, like use case and discuss. Thank you so much.